Hello guys, this is the lesson 4.5 and 4.6 review. You guys should have the sheet and have gone through it yourself. Again, this is just for your reference. If you have trouble, please watch this video and see what you're supposed to do. And I hope that this would explain how to do these. Okay, so I'm going to do it I'm going to do every single question step by step. Most of them are very, very easy if you remember all the rules that I've taught you. Okay, so let's look at number 1. Okay, it's 10 to the 6th power times 10 to the 7th power. So this is a product and we have the same base, right? Therefore, we just take the same base and we add the exponent, right? So that will just simply becomes 10 to the 13th power. Okay, 10 to the 6 times 10 to the 7, same base. Therefore, we add the exponent. Okay, simple as that. Number 2 is easy, right? Same base, 11 and 11 are the same. Yes, they have the same exponent, but that doesn't really matter here. The bases are the important things. So as long as the bases are the same, then you can add exponents when it's multiplications. So it will become 11 to the 4 plus 4, right? You add the exponents, so it becomes 11 to the 8th power. Okay. Number 3, this is the quotient or division, right? And when you have a division or quotient with the same base, in this case base 6, then we can subtract the exponents. So it will become 3 minus 2. So it will become 6 to the 1 power. But we really don't write 1 power. We just leave it as it is. So we don't write the power. Then we know there is always power of 1. Okay. And number 4, this time it's a 7, right? Is the base. So 7 to the 20th divided by 7 to the 4th power. So it would just become 7 to the 20 minus 4, which would be 7 to the 16th power. Okay, so as long as the base does the same, they're very, very simple. Again, we're doing simplifications, and this time we have variables. So, you know the rules. You do the signs, numbers, and variable all separately. Okay, so number 5. A to the 4th power times a to the 8th power. So that's a product, and you have the same base a. So this is a to the 4 plus 8, or a to the 12th power. Okay, simple as that. Number 6, we have 3. We have number here. Okay, so just keep the number as it is, right? There's no other number there. So 3 just remains as 3. It's the w, right? W to the 3rd times w square. That's what we need to do. And that's a w to the 3 plus 2 power, or 3 times w to the 5th power. Please be careful. A lot of times what I see is that when I see 3 and 2, a lot of students just kind of multiply 3 times 2 and then write 6 power. No, we add the exponents. We don't multiply the exponents. Again, the expression is multiplications. It is a product, but we add exponents. Okay, remember that. All right. Number 7, we have numbers 3 and 6. Again, they are being multiplied, so you have to multiply 3 and 6. So you get 18 from that. And then we have n to the 4th and n to the 9th. Therefore, that's n to the 4 plus 9, right? Same base, we add the exponents of those bases, right? So that's 18 n to the 13th power. Okay, so please write the exponent as a superscript. What that means is you have a base, right? And we need to write it on top, right? That's superscript. Okay, so superscript. Okay, so you have to write it on top. Okay, so do be careful. If you write 18 and 13, right, as on the same line, that would be considered wrong, okay? This time we have x squared times x times x. We have one more, but that's okay, right? We just need to add them up. Don't forget though, x has a 1 power on top, so this would become x to the 2 plus 2 plus 1, or x to the 5th power. Many students forget that 1, so they just write x to the 4th power. No, you have to include that. Right, there's a 1 there, 1 there, so you need to include that 1. Okay? And number 9 is the divisions, right? So we know it's a subtraction of the exponents since that they have the same base, x and x. So this will become x to the 9 minus 4, or x to the 5th power. So in fact, the answers are the same for number 8 and number 9, but we get it different, right, in a different way. Okay. Number 10 is a little bit tricky. Okay, and this is where you need to be careful. Again, signs and numbers and variables are separate. Okay, so you need to do 24 over 18. You need to simplify that separately. But also you need to simplify the variable expression. That's m to the 11 minus 3, right? Because that's again, 11 is the power and 3 is the power. So they have both same base m, right? So 11 minus 3. So 24 and 18. What goes into 24 and 18? You know how to simplify this now, right? So I'm thinking 6, right? 6 times 4, right, is 24, and 6 times 3 is 18, right? So you can divide the top and the bottom by 6. So you will get 4/3, right? And then we have m to the 11 minus 3 should be 8. So 4/3 m to the 8th power. That would be the answer for number 10. Again, I would put a star next to it and make sure you understand that, right? Because that's a lot of times I see students struggle with that, okay? Because they don't do separate operation for numbers and variables. Number 11, so the Great Pyramid. The Great Pyramid in Egypt is composed of about 2 to the 21th power. That's a lot, right? Limestone and granite blocks. The average mass of one of these blocks is about 2 to the 11th kilogram. So use the product power properties to approximate the total mass of kilogram of the Great Pyramid. So obviously you have, this is a number of stones and blocks, and then each block is about this much. So the total weight, right? Total weight should be given by the weight of one block, right, times the number of blocks, right? Therefore, weight of one block is 2 to the 11th power times number of block is 2 to the 21th power. Therefore, since the bases are the same, so you write the same base, right? And we add the exponents, which will simply be 2 to the 32. Okay? 32nd power. That's big. That's huge. Okay? Again, I'm not really going to be concerned with units for this one because we're just doing math. But the unit should have been kilogram because this is, each block is, 2 to the 11th kilograms. So this is the kilogram per block. And this is number of blocks, that the final unit should be kilogram. But it's okay. If you don't write the unit for this problems, then I'll be okay as long as you show me that you get 2 to the 32nd power. Okay? All right, so find the missing exponent. So we need to kind of think, right, this time, right? Number 12, okay? So we need to kind of see that, oh, so we got a to the something minus 3 gave you a to the 5th power, right? So which means this something question minus 3 should have been 5, right? Because it's a subtraction, it's a quotient, right? Which means what? I can just kind of add 3 on both sides and figure out that question mark should have been 8. Okay, so you can figure out the missing one by just kind of doing operations. Same thing here, it's a multiplication. So when you are supposed to add them, right? So it's supposed to be b to the question mark plus 6 is supposed to be b to the 7th. That kind of tells you that, you know, whatever that number is plus 6 supposed to be 7. So if you subtract 6 on both sides, you know question mark should have been 1. The missing exponent should have been 1. Okay. All right, number 14, simplify, right? This time we have 2 different variables. But again, we need to have the same base. So y, we can't really do much about. So we need to rearrange this. So it's the x that we can combine. So x squared times x cubed we can do. And then we need to do y to the 4th, right? So x squared and x cubed, right? That's what we need to do. So that's x to the 2 plus 3 power. We add the exponents. But y to the 4th we can't do. We just leave it as it is. So it becomes x to the 5th power times y to the 4th power. And that will be it. You can't combine anymore. Please do not multiply or add these exponents. They have different bases, okay? Because they have different bases, you can't do that. Okay, you have to leave it as it is. All right, 15. Again, this is the quotient that is really hard, but as long as you do it all separately, you will be okay. In other words, you do 14 over 4 separately, and then a is 3 minus 1, right? Why? Because again, it's 3 on top, and a by itself is 1 on top, right? And then we have b, 4 minus 1, because again, 4 on top, and b by itself has 1, right? Therefore, you can simplify. 2 goes into 14 and 4. It should be 7 over 2. And then we have a to the 2nd power, 3 minus 1, times b to the 4 minus 1, or 3rd power. And that's it. You can leave it as it is. Okay? Now, negative exponents, right? Remember, negative exponents was reciprocal, right? Or 1 over. So that negative simply means 1 over 13 to the 6th power. And you're done, because they want you to write with a positive exponent. And that's how you do it, right? And number 7, again, easy. That's just 1 over, right? A to the 9th power. Again, you don't have to put it in a calculator. You don't have to do anything. In fact, if you do that, sometimes you will be too big of a number so the calculator won't give you the answers. So you can just leave it as it is. Okay? Now, number 18. This one you need to be a little bit careful. Why? Because we know anything to the 0 power, right, is equal to 1 as long as a is not equal to 0, right? As long as a is not equal to 0, anything to the 0 power is always equal to 1. However, only the y has that 0 power. X does not. So x just remain as it is. Be careful, please, here, right? You need to be careful. Now, if it was x and y in the parentheses and then have a 0 power, then the whole thing will just become 1, because the 0 power applies to everything inside. However, here, that 0 power only applies to y, so x remain as it is, right? Therefore, you will have y to the 0 is just simply 1, So x times 1 is just x. So y kind of disappears. Okay. Same here, right? That negative fifth power only applies to g, not to 6. So 6 remain as it is. You do not touch 6, right? But the g has 1 over, right? G to the fifth power, right? So you can just kind of write it as a 6 over g to the fifth power. So when you have negative, it's as if like it goes in, okay? All right, number 20. Now this time we're doing reverse. So fraction bars. So we have many ways to do this. First, I can simply write, oh, that's a 25 to the negative 1 power. So I can do that, right? Because anything has a 1 power. So you can kind of think of it as a 25 has 1 power. So I can write it as a 20 because it's 1 over. So I can write 25 to the negative 1 power. Or you can also do 25. If you recognize 25 is 5 squared, right? Therefore, you could also write this as a 5 to the negative second power. Both of them would be the correct answer. I would accept that because, again, you wrote expression without the fraction bar. 21, same thing. You can write it as a 10,000 to the negative 1 power. Or 10,000, you should know that that's 10 to the fourth power, right? Because it has a 4 0, right? 1, 2, 3, 4. So that's a 10 to the fourth power. Therefore, you can also write that as a 10 to the negative fourth power. Okay, so you can simplify that way. Now, 22, you need to be a little bit careful. Again, 8 is on top. We don't touch 8, right? But it's the bottom one, right? So in order to bring it up, because we don't want fraction bar, what do? Just change the power from positive to negative. That's it, right? So it just simply becomes 8 c to the negative fifth power. That's it. It's just focus on what you need to do, right? How do you get rid of the fraction bar? You get rid of denominator. And how do you get rid of the denominator? By putting negative power, okay? Same here, number 23, right? 4y just remain as it is. You don't touch that. You don't touch the numerator. It's a denominator. That's x to the third power. It will become x to the negative third power. Simple, right? All right. So number 24. So scientists discover that nanoparticle of a substance called slacked lime can help preserve historical documents. The diameter of these nanoparticles are less than 1 over 100 billionth, right? 100 billion, 1 over 100 billion meter. So write this number using negative exponents. Easy, right? Again, one way you can write it as 100 billion, right? And then with minus 1, you can do that. Or you can also write this as a 10 to the, this one has how many 0? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? So negative 11. So either way is fine, okay? Obviously, I would prefer this one than big numbers like that, okay? So find the quotients. Again, it says write the answer using only positive exponents. So first, when you do this operation, you know you're supposed to subtract the exponents because it's a quotient. So it's 2 to the 5 minus 8, but that's equal to 2 to the negative third power. But they only wanted a positive exponents. Therefore, we need to rewrite this as a 1 over 2 to the third power. Okay. Number 26. Again, same power, 16 and 16. So that's 16, but be careful. Be careful with the negative. It's negative 9 minus negative 8. Ooh, double negative, right? So it becomes 16, negative 9 plus 8. So negative 9 plus 8 becomes 16 to the negative 1 power, right? Negative 9 plus 8, negative 1 should be equal to 1 over 16 to the 1 power, right? Or just write it as a 1 over 16, and that's fine. Okay. Number 27. 17, that's just by itself. You don't touch that, right? That's in the numerator, so you leave it as it is. But a becomes third power minus 7, right? This is divisions. So it becomes 17, and then a to the negative fourth power, 3 minus 7. Then we need to write it with the positive exponents, so you don't touch 17, but a goes on the bottom with the fourth power. Okay? So number 28. Again, leave the number as it is, right? So 26 over 13, leave it as it is, and you do w, the negative fourth power, minus negative 12, so double negative, be careful with that. Now 26 and 13, you should see that 26 is divisible by 13, so in fact, it just simply becomes 2. So you get 2 times w, that's negative 4 plus 12, right? Double negative. So that becomes 2w, that's negative 4 plus 12, which is positive 8. And since it's positive, you can just leave it as it is. Okay. 2 more. So find the quotients, right, using only positive exponents, right? So the symbol has to be done separately. So a to the 6 minus 3 times b to the 4 minus 7. So a will have a positive exponent because 6 minus 3 is 3. But b will have negative exponent because 4 minus 7 would be negative 3. So a to the third will stay, but b to the negative third will change to 1 over b to the third power. Okay, and that would be it. And again, this one, so you do separately m to the 8 minus 2 and n to the 4 minus 9, right? So that's m to the 6th power, but n would have negative 5th power. So m to the 6th power will remain, but n has a negative, so it goes down to the positive power 5. Okay? And that's it. So yes, I understand these are confusing, so please, you need practice. Don't forget, we have a test on Monday. I will go over everything in chapter 4 tomorrow, but you need to know how to do this very, very well because this is very important skill. So I hope you practice. Okay? All right. I'll see you tomorrow. Have a nice day.